Day 3, stretches. So a stretch is a transformation in which the distance of each x-coordinate or y-coordinate from the line of the reflection is multiplied by some scale factor. Unlike a translation or a reflection, a stretch actually changes the shape of the graph. So from our Desmos demonstration of the following radical function, we should recognize or see that by multiplying the entire function by 3, there was a vertical stretch by a factor of 3. Here, if the function is multiplied by 1/2, there is a vertical stretch by a factor of 1/2. So what does that mean? It means that when the entire function is being multiplied by a specific stretch factor, that means it's going to affect y coordinates on our graph by that multiplication value. So all of our y coordinates are going to be multiplied by a factor of 3 here, and all of our y coordinates here are going to be multiplied by a factor of 1/2. Okay? And then in C and D, if we x with a 4x, we should see that this is actually a horizontal stretch by a factor of 1/4. So then actually end the circle of this stretch factor. And this is also a horizontal stretch by a factor of 3. So 1/3, a stretch factor of 3, and 4, a stretch factor of 1/4. So what actually is happening here is these values are affecting all of the x coordinates on the graph by stretching or giving it a multiplication value of the reciprocal of this value. So the reciprocal of 4 would be 1/4, reciprocal of 1/3 is 3. Kind of gotten that out of the way. Given this example, given the function y equals f of x, apply the following transformations to each graph by drawing the new image, then state the invariant points. So if this is my original function y equals f of x, and I'm taking f of x and I'm multiplying it by a stretch factor, a vertical stretch factor of 2, then that's exactly what's going to affect my y values of each of those points on my graph. So point A, that's currently at -4 and 4, I'm going to stretch this by a factor of 2. So my y value, that's 4, is going to be twice the distance it is from the x-axis currently. So right now it's a distance of 4 units from the x-axis. It's now going to be doubled that to be 8. So this would be 8 prime. Point B, this -2, 0, well, if I stretch the y value by a factor of 2, so we're thinking multiplication, if I multiply 0 by 2, it's actually not going to change. So this point is going to stay the same. This point here at C has a distance of 2. It's now going to be 4. Point D does not change. And point E is going to be double that, which is now going to be 8. So my new graph, my transformation, the actual distance horizontally has not changed, but we can see that it is definitely changed or being stretched vertically by a factor of 2. Our invariant, again, are points that did not change after our transformation, and that would be point B, which is at -2, and point D, which is at +2, 0. So again, a vertical stretch, our invariant points are going to be points that occur on the x-axis. All right, moving on. Okay, again, we've taken the same function. It looks a little bit wider because this just zoomed in the scale a little bit more. Here we're asked to transform f of 4x. Well, 4x, this tells me because it's being applied to inside the brackets to x, this tells me it has to be a horizontal stretch. And it's going to be a horizontal stretch by a factor of the reciprocal of that value. So what am I doing? That means I am physically the distance horizontally my x values have from the y-axis and multiply those values by 1/4 or stretch it by 1/4. So this value at -4 is 4 units from the y-axis. If I multiply that value by 1/4, that distance is now going to become a -1. So there's A prime. This point here at -2, 0, if I stretch 2 by 1/4, that's now going to be -1/2. So there's point B. Point C is going to stay the same because my x value is at 0. If I stretch by 1/4, it's not going to change. This point here at D, 2 units from the y-axis, stretch it by 1/4 is going to be 1/2, and E is going to be 1. So what is my new graph going to look like? As we can clearly see by the graph, nothing has changed vertically. All of the points, all of the y coordinates are still the same, but it has been stretched by 1/4. So originally this graph was a total distance across it. That total distance should now be 1/4 that distance. Well, 1/4 of 8 would be 2, which is now this total distance. So we can clearly see a horizontal stretch happening. Okay, so this just outlines what happens with vertical stretches, what affects a vertical stretch, or what affects the horizontal stretch. So vertical stretches, we denote this value outside here as a letter A. A horizontal stretch, we denote this value inside the brackets as letter B. Remember, horizontal stretch is always the reciprocal of your B value. Vertical stretch is always whatever that A value is. Okay, mapping notations kind of similar. X comma Y would become a vertical stretch would be X comma whatever A is times the Y value. Mapping notation, X comma Y, remember we're taking the reciprocal and multiplying it by X for a horizontal stretch. Okay? All right, so moving on to a few more examples. Right.